All right, you're watching the video key for practice 2.5/2. I'm not going to do the whole thing, but I will do a block of problems that you can watch along with the video and do with me as well. My last video was a little blurry, so I'm going to kind of zoom way in on this one, and hopefully that will help. I'm filming this in advance of our class, but I'm hoping we'll have some time to work through some of these. So just like last time, I'm going to flip it over to the back section and maybe just start here at the top at number 13. Because if you can do like 4 or 5 or 6 of these problems, you should be able to do all 24 of them, hopefully. So find the measure of the specified angle and round to 3 decimal places. That's our instructions up here at the top of the page. So what we're learning is that we're still going to use our ideas of sine, cosine, and tangent, but we're now going to use what we call inverse trig functions. And on this worksheet, you are always solving to find this angle labeled A. So I want to know, what is that angle? So again, we're going to still label this like we did when we're finding the side. I know 15 is my hypotenuse. 11 is going to be opposite angle A, and this unmarked side is adjacent to angle A. So if I look at what I have, I am given the hypotenuse is 15, and the opposite side is 11. So if I think about Sohcahtoa, if I have an opposite and a hypotenuse, I'm going to use sine. And if you didn't catch our last video, just to go over that, we said sine is the ratio of opposite to hypotenuse, cosine adjacent to hypotenuse, tangent opposite to adjacent, and Sohcahtoa is a little acronym that we can use to remember that. And like my geometry teacher taught me that when I took geometry. It's just one of those things that every geometry teacher says, Sohcahtoa. All right, so if we want to set this up, the first thing I want to see is that you write it almost like we do know the angle. So we said we're going to use sine, so we would say the sine of angle A equals opposite over hypotenuse 11 over 15. So we won't be able to figure out what angle A is with using the sine function, but we're going to now translate to the inverse sine. So all we're going to do is the inverse sine is going to be like sine to the -1 power. That's how we represent an inverse in math. And we're going to switch the angle A and this fraction. So I will say the inverse sine of 11/15 equals A. This is something that you can put into your calculator. So again, you need to make sure your calculator is in degrees. If it's in radians, it will give you angle A in radians. I'm going to try, I don't think I can put these on the same screen. Squeezing this in here. So we're going to enter this, the inverse sine of 11/15 equals A. So inverse sine, on the graphing calculator, you're just going to hit the second menu, in mine it's blue, and then you'll hit that sine button. So I'm going to hit second sine. So second, and then the sine, and you should see that little sine to the -1 power. And then we said we're doing the inverse sine of 11/15. I checked, my calculator is in degrees, I can see that up here. So 11 divided by 15. You can close the parentheses, I don't think you even need to. It tells us that that angle is 47.11657 degrees. I'm going to round to 47.167. Now these triangles are most likely not drawn to scale, so if you get out a protractor to check your work, I'd be very surprised if this angle actually is 47.167. It's very hard in Microsoft Word to create angles that are drawn to scale like that. But all right, that's what we get for number 13. Let's take a look at number 14. All right, in 14, here's angle A. We've got the hypotenuse. The opposite side is unlabeled. The adjacent side is 12. And we are working with adjacent and hypotenuse. So this is going to be our cosine. So again, the two things I really want to see when you show your work, first is this statement. Cosine of angle A equals adjacent over hypotenuse 12 over 19. Sorry, I bumped the camera with my pen. All right, so 12 over 19. Then we will rewrite that using the inverse function, and I'll see if I can squeeze it in underneath. The inverse cosine, so that's like cosine to the -1 power of 12/19 will give us A. So again, this is an inverse function. It's like doing the opposite of cosine, and we use it to work backwards and find the angle when we know the sides. So we said, oh, I already forgot, 12 over 19. So the inverse cosine of 12 divided by 19, and we will round that, so 50.833. Sorry, my camera's really close to my paper. 50.833. All right, and that was problem 14. Let's do 15. We'll just maybe do a couple more. So in number 15, here's angle A. We've got a hypotenuse. We've got an opposite side, which is 31, and we've got the adjacent side, which is 12. So if you look, we've got an opposite and an adjacent. Sorry, I realized this was going off the screen. So opposite and adjacent, that is TOA. That's our tangent function. So we're going to say that the tangent of angle A, and remember it's got to be opposite over adjacent, that order matters, is 31 over 12. Then we want to change this to our inverse function. So the inverse tangent of 31 over 12 equals A. And that's what we'll plug in the calculator. So inverse tangent, again, we'll get that by doing second tan. So second, I know you can't see me pushing the buttons, but second tan, and even if you're using a scientific and not graphing calculator, it should be second tan, I think. I think it's the same in all. And we said 31 over 12. All right, we get 68.8387, so 68.839 is what we'll round that to. After today, you will know how to do all of the problems that are on the mile marker. Well, in theory, you will have learned how to approach all the problems on the mile marker. So again, this attention to rounding and knowing that we rounded that 8 up to a 9 because of the 7 that came after it will be really important for our mile marker. All right, so that was number 15. And you know what? I think we're good with just those 3 examples. As I look on the sheet, I really don't think there's anything on this back page that stands out as being really that different. We got a sine, a cosine, and a tangent. And again, watch out for how you label these. Like, make sure you're using the correct ratios, opposite to adjacent, not adjacent to opposite, and make sure you're choosing the correct functions. And feel free to reach out to me if you need help. Good luck.